The waters south of Japan have carried many names. Sailors once called them Ma no Umi, the Sea of Evil. Later, Western writers would rename the region the Dragon's Triangle. Today, it is better known as the Devil's Sea. On maps, it looks ordinary. It lies east of Taiwan, south of Japan, and north of the Mariana Islands. A wide stretch of open ocean, crossed by trade routes for centuries. No clear boundary marks where it begins or ends. No warning lines appear on nautical charts. And yet, for hundreds of years, this area has carried a reputation. Ships that vanished, compasses that failed, fishermen who never returned. Unlike many deep-sea mystery stories, the Devil's Sea is not based on a single event. It is a pattern built slowly from many small losses. The earliest written accounts come from Chinese and Japanese sources. As early as the 8th century, Chinese records mention dangerous waters east of the coast, where ships were sometimes lost without clear cause. Japanese fishermen told stories of glowing lights on the horizon and sudden storms that rose without warning. These were not supernatural claims at first. They were practical warnings. In medieval Japan, the region was known for unpredictable weather and strong currents. Sailors avoided it when possible. When they had to cross, they traveled in groups and kept close to the coast. Over time, something changed. By the Edo period, some chronicles began to describe the area as cursed. Not just dangerous, but hostile. A place where ships disappeared and were never found. The reputation hardened in the 20th century. In the 1950s, Japan experienced a wave of unexplained maritime losses. Fishing boats failed to return. Cargo ships vanished on routine routes. In some cases, wreckage was never recovered. One incident stood out. In 1952, the Japanese government launched a research vessel named the Keio Maru No. 5. Its mission was to study underwater volcanic activity near the island of Myojinsho, an area known for recent eruptions. The ship carried 31 people. During the expedition, the vessel disappeared without sending a distress signal. Days later, debris was found floating at sea. No survivors were ever recovered. An official investigation concluded that the ship had been destroyed by a sudden volcanic explosion. But the public response was different. Newspapers began linking the loss to older legends. Writers drew comparisons to the Bermuda Triangle. The term Devil's Sea entered popular language. Soon, every disappearance in the region was grouped under the same label. This is how the myth took shape. Not from ancient curses, but from modern fear layered onto older warnings. To understand what truly happens in the Devil's Sea, we have to look at the ground beneath the water. Geologically, this region is one of the most active places on Earth. It lies along the Pacific Ring of Fire, where several tectonic plates meet. The Philippine Sea Plate, the Pacific Plate, and the Eurasian Plate all interact here. Their movement creates frequent earthquakes and underwater volcanoes. The seafloor is unstable. Underwater mountains rise and collapse. New islands appear and vanish within years. Vents release hot gases and ash into the water. This alone makes navigation risky. But there is more. Oceanographers have identified strong and shifting currents in the region. These currents can pull small vessels far off course in a short time. In bad weather, ships can be driven into deep ocean basins where wreckage sinks quickly and is rarely recovered. This explains part of the mystery, but not all of it. One of the most debated features of the Devil's Sea is the role of methane gas. In several areas of the Western Pacific, large deposits of methane hydrate lie trapped beneath the seabed. When disturbed by earthquakes or volcanic activity, these deposits can release gas suddenly into the water. This changes the density of the sea. In theory, if enough gas is released at once, the water can lose buoyancy. A ship passing over such a plume could lose support and sink rapidly. This idea has been tested in laboratory models and small-scale experiments. It is physically possible. Whether it happens often enough to explain real disappearances is still debated. Japanese researchers have confirmed the presence of methane hydrate in parts of the region. They have also recorded sudden gas releases near submarine volcanoes. But linking these events to specific ship losses remains difficult. There is another factor that shaped the legend: navigation. Before modern GPS, sailors relied on magnetic compasses. In the Devil's Sea, magnetic readings are known to be unstable in certain zones. This is caused by variations in the Earth's magnetic field and by volcanic rock on the seabed. A small compass error can send a ship dozens of kilometers off course over long distances. Several recorded losses in the early 20th century were later explained as navigation errors. Ships ran out of fuel, missed shipping lanes, or drifted into open ocean. They did not vanish. They were simply never found. This pattern matters. When wreckage is not recovered, the human mind fills the gap. A missing ship becomes a mystery. A series of missing ships becomes a legend. By the 1960s, Western writers began to group the Devil's Sea with the Bermuda Triangle. Books and magazines listed dozens of supposed disappearances, often without checking original records. Some incidents were exaggerated. Some never happened. Some occurred far outside the actual region. This does not mean the area is safe. It means the story grew faster than the evidence. Japanese maritime records show that the number of accidents in the Devil's Sea is not much higher than in other busy and dangerous waters. Storms, equipment failure, and human error explain most cases. Yet a small number of incidents remain unclear. Ships that send no distress signal. Vessels that vanished in calm weather. Losses that cannot be fully reconstructed from surviving data. These are rare, but they are real. This is what keeps the mystery alive. Not the legend. The gaps. Several of the incidents that shaped the reputation of the Devil's Sea are known by name, not legends. Real ships, real dates, real crews. By tracing these cases one by one, a clearer picture begins to form. One of the earliest well-documented losses occurred in 1944, during the final year of the Second World War. A Japanese cargo ship named the Shinyo Maru left Yokohama bound for Taiwan. It carried military supplies and a crew of 38. The route passed through the waters south of Japan, close to the later defined Devil's Sea zone. The ship never arrived. No distress signal was received. No wreckage was found. In wartime, such losses were common. Submarines, mines, and air attacks destroyed hundreds of vessels. But in this case, no enemy action was recorded in the area. After the war, Japanese naval historians reviewed the loss and listed the cause as unknown. This was not unique. Between 1945 and 1955, Japanese maritime records list more than a dozen vessels lost in the same general region, with causes marked as uncertain. Most were small fishing boats. Some were research vessels. Few left clear evidence behind. The most famous case remains the Keio Maru No. 5. In September 1952, the ship sailed toward Myojinsho, a newly formed volcanic island that had erupted several times in the previous year. Scientists were eager to study the activity up close. The vessel carried geologists, oceanographers, and crew. On September 24, radio contact was lost. Days later, pieces of wreckage were recovered. Burned wood. Twisted metal. No bodies. An investigation by the Japanese Maritime Safety Agency concluded that the ship had been destroyed by a sudden volcanic explosion beneath the water. At the time, Myojinsho was extremely unstable. In fact, only a few months later, a violent eruption destroyed the island itself. This case is often cited as a classic Devil's Sea disappearance. But in reality, it is one of the best explained. The danger was known. The cause was identified. The tragedy was the risk taken, not the mystery. Another case, however, is less clear. In 1957, a Japanese fishing vessel named the Takara Maru left port for a routine trip. Weather reports showed calm conditions. The crew was experienced. The ship was well maintained. It vanished. No distress call. No wreckage. No storm reported in the area. Later searches found nothing. The official conclusion was unknown cause. In the same decade, 3 other fishing boats disappeared within a span of 5 years in nearby waters. This cluster of losses, small in number but close in time, fueled public fear. Newspapers began to speak of a cursed zone. Writers compared it to the Bermuda Triangle. Soon the idea took on a life of its own. But when modern researchers reviewed these cases, patterns emerged. Several of the vessels were old. Some had engine problems reported before departure. Others were traveling without radio operators at all times. In at least 2 cases, storms were recorded in nearby areas but not at the exact coordinates later assumed. In other words, uncertainty remained but not impossibility. The problem with sea disappearances is simple. The ocean erases evidence. If a ship sinks in deep water, it may never be found. If it breaks apart, debris may drift far from the site. If no one sees it happen, the moment is lost. This creates a special kind of mystery. Not one built from strange events, but one built from missing information. This is where the Devil's Sea differs from many myths. There is no single unexplained event that defies physics. There is only a series of losses that share a dangerous setting. When scientists began to study the region more closely in the 1970s, they focused on 3 main risks. First, underwater volcanoes. More than a dozen active volcanic centers lie beneath these waters. Some erupt without warning. Explosions can send shock waves through the water strong enough to damage hulls. Second, seismic activity. Earthquakes are frequent. Even small ones can trigger underwater landslides. These can generate local waves and sudden changes in depth. Third, gas release. As mentioned earlier, methane plumes have been observed near volcanic areas. Japanese research vessels recorded sudden drops in water density in small zones. No confirmed case shows a ship sinking from this cause. But the risk exists. Navigation adds another layer. Before satellite tracking, ships that drifted off course could wander for days without being noticed. A disabled vessel could sink far from shipping lanes. In this way, a practical danger zone slowly became a legendary one. By the late 20th century, most shipping companies no longer avoided the region. Modern navigation, weather forecasting, and stronger hulls reduced the risk. Accident rates fell. The legend remained. Today, the Devil's Sea is no longer marked on official maps. But its name survives in books, documentaries, and online lists of mysterious places. This raises an important question. Is the Devil's Sea truly unexplained? Or is it an example of how human fear turns risk into myth? By the time Western audiences learned about the Devil's Sea, the story had already changed. In Japan, the region was known as dangerous. In the West, it became mysterious. The turning point came in the late 1950s and early 1960s, when a few English-language articles began to mention a Pacific Bermuda Triangle. These early reports relied on second-hand summaries of Japanese losses, often without original sources. Numbers were rounded. Details were simplified. Soon, lists of vanished ships began to circulate. One of the first popular writers to promote the idea was Ivan Sanderson, a British zoologist who wrote about vile vortices around the world. He grouped the Devil's Sea with the Bermuda Triangle, the South Atlantic, and parts of the Indian Ocean. His theory suggested hidden forces at work. Magnetic anomalies, energy fields, unknown natural powers. These ideas were not based on measurements. They were based on patterns drawn from incomplete data. Later authors expanded the lists. Some included ships that sank far outside the region. Others counted wartime losses caused by submarines. A few even added aircraft incidents with no connection to the area. Over time, the Devil's Sea became less a place and more a symbol. A place where disappearances could be placed without question. This process is well known to historians. When records are thin, stories grow. When stories repeat, they harden. By the 1970s, the Devil's Sea had entered the same category as the Bermuda Triangle, a mystery that sold books. But Japanese researchers were uneasy with this image. In the 1980s, the Japan Coast Guard released a detailed review of maritime accidents in the region over a 100-year period. The report compared loss rates in the Devil's Sea to other busy sea lanes around Japan. The result was simple. The region was dangerous, but not unusually so. Storm frequency was high. Volcanic activity was real. Navigation was difficult. But accident rates matched what would be expected for such conditions. There was no spike. No cluster that defied statistics. This did not end the legend. It complicated it. Because even when a mystery is explained in general, individual cases can still resist explanation. and those cases matter. One such case occurred in 1978. A small Japanese cargo ship, the Ryujo Maru, reported engine failure south of Tokyo. Weather was stable. A rescue vessel was dispatched. When it arrived, nothing was there. No ship. No debris. The last radio position placed the vessel in deep water. Searches continued for days. Nothing was found. The official conclusion was sinking by unknown cause. This case was never linked to volcanoes, storms, or gas. It remains open. Another case involved a Taiwanese fishing boat in 1983. The vessel sent a brief message reporting heavy vibration beneath the hull. Contact ended minutes later. No eruption was recorded. No earthquake. No wreckage. Investigators suggested structural failure. But no proof was found. These are the incidents that keep the story alive. Not the dozens that can be explained. The few that cannot. From a scientific view, this is not surprising. In any large and dangerous sea region, some losses will remain unclear. Records fail. Witnesses are absent. Technology is limited. Mystery is not evidence of the unknown. It is evidence of missing data. This is where the Devil's Sea becomes a lesson in how legends form. First, a dangerous place gains a warning name. Second, a few tragic losses occur. Third, modern media groups them together. Fourth, repetition turns pattern into myth. By the time scientists arrive, the story is already shaped. And yet, the region still resists full certainty. Even today, underwater mapping shows unstable slopes and unknown volcanic vents. New submarine eruptions are detected every decade. Gas plumes are still measured. The ground beneath these waters is not quiet. So the Devil's Sea remains what it has always been. Not cursed. Not supernatural. But genuinely complex. A place where geology, weather, and human error overlap. A place where some questions remain unanswered. When the story of the Devil's Sea is set aside from its legend, what remains is something more subtle. Not a haunted ocean. A fragile border between knowledge and uncertainty. Most of what happens in this region can be explained by forces we understand. Tectonic plates grind slowly beneath the water. Volcanoes rise and fall. Currents shift without warning. Weather forms quickly. These are not mysteries. They are risks. But in every dangerous place, there will always be a small number of events that escape clear explanation. And those few events shape the memory. The Devil's Sea teaches an important lesson about unexplained history. Mystery does not require the impossible. It only requires silence. A missing ship. A failed radio. A body of water too deep to search. From that silence, stories grow. In the 20th century, when technology promised full control over the seas, every unexplained loss felt more disturbing. People expected answers. When none came, imagination filled the space. This is why the Devil's Sea and the Bermuda Triangle rose at the same time. Not because the oceans changed. Because human expectations did. We came to believe that everything could be tracked. When it was not, we felt something had gone wrong. Yet science continues to narrow the unknown. Today, satellite tracking follows most commercial ships. Seismic sensors record underwater eruptions. Weather systems are mapped in real time. Magnetic charts are more precise than ever. As a result, modern disappearances in this region are rare. When accidents happen, causes are usually found. The mystery is shrinking. But it will never disappear completely. Because the ocean is large. And human records are fragile. In this sense, the Devil's Sea belongs to a wider family of deep-sea mystery stories. Not stories about monsters or lost continents. Stories about how little of the past we can ever fully recover. Ships sink. Logs are lost. Memories fade. Later generations are left with gaps. Sometimes those gaps become legends. Sometimes they become science. Often they become both. The Devil's Sea also shows how cultural memory works. In Japan, the region is now discussed mostly in geological terms. In the West, the myth still circulates. Two stories built from the same events. This reminds us that mystery is not only about facts. It is about how we tell them. In the end, the Devil's Sea is not terrifying because it is unknown. It is unsettling because it shows how easily the unknown is created. A few losses, a dangerous setting, a long silence, and a name that carries fear forward. What remains today is not a cursed triangle, but a stretch of ocean that continues to move, erupt, and change beneath the surface. A place where science still studies, and where a small number of questions remain open, not as proof of the supernatural, but as proof that the sea still keeps some of its stories,